Hello viewers and my dear students. Welcome to one-dimensional problem analysis. This is session 3. Now I am showing you a demo on one-dimensional problem analysis using Ansys. And as you know, this is session 3. In session 1 we have covered the theoretical aspects. Session 2 we have covered some of the aspects related to Ansys also, and we have already started with the problem. And this is the problem given. As you see, this is the problem given. Theoretical approach is already over in 1, and using Ansys Release 14 we are doing, and to some extent we have covered already, and we'll continue the same thing in this session. Okay. Now as you see here, in this preferences and all that I have given already structural, and the element I have given 180 I have already given. Okay, this 180 I have already given, and the real constants, no, real constants you do add, edit, delete, add. There are two materials here. Okay, you see here there are two materials here. First material is steel, second material is aluminum. First material area of cross section, as you know, it is 900. You put area as 900. Okay, this is very important. Don't forget to do this. Okay, that is real constant set number 1. This is for steel. Area of cross section is 900. Put area of cross section 900. Just say apply. Okay, then you go for real constant set 2. Real constant set 2. This will be that is aluminum, and this has a cross sectional area of 600. Okay, then you say okay, that means I have created two sets. Set 1 is for steel, set 2 for aluminum. You can edit anytime. Set 1, see here, edit. Okay, you say. Set 1, you see 900, it is correct. Okay, in the same way, set 2 you go, edit, you say okay, and 600 we have. That means we have done correctly. Okay, this is okay. In that way, you just say close. See here, now we have given the real constants. That means the first material is steel that has a cross section of 900 millimeter square. Second one has a cross section of 600. Both are introduced in real constants. Now I'll go for material properties. You see here, I'll go for material properties, material models. Okay, you go for structural, linear, elastic, isotropic. You go. First material, as you know, it is steel. It is 2E5 you put. It is 2, that is 2 into 10 to the power of 5 Newton per millimeter square. Okay. If it is Newton per meter square, I would have made 2E11. But since I am doing everything in millimeter and Newton, I have taken 2E5. That means it is 2 into 10 to the power of 5 Newton per millimeter square. Okay, this you should know. They are given in the problem. This Young's modulus of the material of steel, they are given 2E5, that is 200E3 or 2E5. In that way, this you take it as okay. Okay, this okay. Since there is no since the strain is only in one axial direction, this Poisson's ratio is considered as 0 only, because the stress is applied only in the x direction, and the displacement also is only in the x direction. No y displacement will be there. That is why Poisson's ratio, I will take it as 0. Okay. Now one material is over. Next you take material, new model. Okay. Material ID 2. Just say okay. Now I'll do the same thing, structural, linear, elastic, isotropic. Now for this, it is 0.7 E5. 0.7 E5 is, that is 2 E5 for steel, 0.7 E5 for aluminum. Okay, Poisson's ratio is assumed to be 0. Okay, okay, in that way I have two materials defined. Material 1, this is steel, this is aluminum. Okay, you can just see, if you see here 2E5, what I have done, that is correct for steel. And in the same way, if you see for this, it is 0.7 E5 or 70,000, that is also correct. Okay, in that way, okay you do. material exit you do. That means we have fed the correct materials, that is material properties. Okay, material properties are very important. As you know, the material properties will decide the displacements at different nodes. Okay, did you follow? Material properties, that is, the higher the value of E, lower will be the deformation. Okay, lower will be the deformation. That means, anyway, whatever they are given, we will do. Same thing we have done it by theoretical methods also. We want to get the same answers. That is why we are maintaining the same properties here also. Okay, then you go for modeling. Okay, that is, you see here, as I've told you in the earlier sessions and all that, you should know there are basically pre-processing stage and solution phase and post-processing phase. These are all called pre-processing phase, that is creating models and all that. I'll tell you, whatever we are doing, we are all under pre-processing phase. Okay, modeling, create key points. In active coordination you do key point 1, let us say 1 is 0 0 0 you take 1 0 0 0 you take. Okay, just say apply. Then key point 2 you take. Key point 2, if you see, it is 600. This is end of steel. 600 is the length of the steel. This 600 0 0 you take. Say apply. Then take 3, that is end of aluminum, that is 600 plus 500, that is 1100 you take. 1100 you take, you say okay. Okay, now you have key point 1, key point 2, key point 3. You have got, this is 600, this is 500, totally 1100. Then you create by lines. We will join that by lines. Create lines, straight line. We'll join this and this by straight line. We'll join this 2 and 3 by straight line. Okay, this you do. Okay, this has to be done. Now we have created the modeling part of it. Okay, now you see here, once you have created the model, okay, there are so many things to be done. We'll simulate what exactly we have done with theoretical method. Same thing we'll do. This is, as you know, it is 600 mm. This, you know, it is 500 mm. Everything you know. Okay, now you see here, meshing. This is very important. Meshing, I'm telling you, this is most important thing. If you do any mistakes here, the entire thing will go away. You don't get the proper answers. Okay, now you see here, in this, mesh attributes you go. Picked lines you take. Okay, mesh attributes. We'll attribute the correct properties here. Picked lines you take. Take this line. Once you take this line, you should make the Ansys understand this is steel. Okay, that is why I'll say okay. And you know very well, it is material 1, okay, and real constant 1. Okay, this material 1 is steel. Real constant 1 is, this is 900 mm square, which we already done. That is why 1 and 1 you take and say apply. That means this has been that is designated as steel with Young's modulus as 2 into 10 to the power of 5 and cross sectional area as 900 millimeter square. In the same way, you go click on this line and you should say that this is aluminum 0.7 into 10 to the power of 5 and the cross section is 600 mm square. In that way, you just say okay and compulsorily you change this 2 and 2 you say. Once you do 2 and 2, material number 2 is 0.7 into 10 to the power of 5. Real constant set number 2 is 600 mm square, that you know. Okay, this you do. That means once you do this, it is clearly this material is steel, this material is aluminum. The Ansys will understand clearly that this material is steel, this material is aluminum, and also it understands this material not only is steel but it has a cross sectional area of 900 millimeter square, and this is not only aluminum but it has a cross sectional area of 600 millimeter square. Okay, this you do. Okay, then you see here under size controls, no, size controls you do, manual size you do, lines, okay, picked lines, you pick this, and you can make any number of elements. At least here, I'll make only one. Number of divisions, I'll make only one. Okay. That means this has this element 1, this element 1. Okay. Once you do this, this element has 1, this element has 1. Okay. That means there are two elements only I created. No, not too many. This is 1, this is, because I could have made, okay, I could have done more number of elements are. Okay, but I have done only one. In that way, you see here, now I'll do mesh, lines, pick all I'll do. Okay, now you see here. Now, if you go for list, elements, attributes and real constants, if you see here, I have first element and second element. Only two elements I have created. First element has a cross-sectional area of 900. Second element has 600. If I give a number of divisions 5 and 5, 10 elements would have been created. Now I have created the number of divisions as 1 for both the lines. Hence I am able to create only 2 elements. 2 elements. As a result, there are 3 nodes only. Okay, list. If you nodes, if you click, okay. Okay, list nodes, no. 1 is 000, 2 is 600, 300, 1100, 00. In that way, list, there are only 3 nodes here. 1 here, 2 here, and 3 here. Okay, that means there are only 3 nodes. And also, you know, node number 1, okay, there won't be any displacement here because it is fixed here. Node number 2, there will be displacement. Node number 3 also, there will be displacement. Okay, anyway, this we have, that is, we have covered up till here. You can call it as pre-processing phase. Now I'll go for the loading. Okay. Now be careful before you do this. Always check whether you have created elements or not. Okay. 2 elements have been created. Now see here, unless elements are created, you won't get the answer. Okay. This you understand. After this, you have to check for whether you have created the elements or not by checking list elements. Nodes attributes and node attributes real constant, and check how many elements are created. We have created only 2 elements. Okay, this you do. Okay, now you see here is you save db, let us say here. Okay, save db here. Okay, now up till here we are done correctly. This is saved. Now here, as I told you earlier, in Ansys there is no undo command. There is no undo command. As a result, you can't undo at any particular stage. Did you follow? There is no undo command. That is why, let us say you do mistake at the later stages and you can't delete. Deleting and all that is a cumbersome procedure. That is why what I'll do, I'll just resume DB. Once I resume DB, since it's a fresh file, go to that one dimension, I'll come to this stage only. And that means that meshing stage, after completion of meshing stage, I'll come to this stage. That is why whenever you make mistakes, in case you make mistakes later stages, you just say resume DB, you'll come to this stage and do properly after that. That is why save and resume will act as undo command in Ansys. Okay, this you clearly understand. Now, this you see here. Now, I have to see here, file, if you go, list, log file, you see here, so much file it has been created. See here, as you see here, whatever you have done, all would have been created here. Okay, that is, elements have been created, meshing has been done. Okay, if you go there, that 600, 1100, whatever that coordinates 100, 2, 600, 00, 1100, 00, everything, and elements, that is properties, no, what you have given, those things also has been recorded here. This EX, you can see that 2 into 70,000. In that way, here you see 2.7 EX 2E5. That is, whatever we have done in this problem, all would have been recorded here. Okay, this you should know. That means this you can copy it and paste it and get the answers and all that. This I'll tell you. Don't worry about that. Now we are concentrating only on, that is, the GUI part, graphic user interface part. Now we have come to the end of session 3. We'll continue this in session 4. Thank you very much, friends, for watching. Thank you.